All right, we'll get started. Our apologies. We're starting a few minutes late this afternoon. We had just a couple of technical issues that we had to get addressed. Good afternoon, everyone. Thank you for joining us today for this webinar entitled The Zika Epidemic, Implications for SLC States, hosted by the Council of State Governments Southern Office, the Southern Legislative Conference. My name is Roger Moore, and I am the Human Services and Public Safety Policy Analyst here at SLC. I would like to extend our sincere thanks to our distinguished panel for setting aside some time today to be on this webinar and share their expertise with us. To begin, I would like to take care of a few basic housekeeping items. You are all currently in listen-only mode. For those who wish to ask a question, you may do so using the question box on your GoToWebinar toolbar. You may type in a question at any time during the presentations. Secondly, please remember we will be recording this webinar and posting it later on the CSG Knowledge Center website at knowledgecenter.csg.org. The webinar will also be available on the SLC website at slcatlanta.org. Today's discussion focuses on the Zika epidemic. As we all know, the Zika virus has received extensive international coverage since the current outbreak was first confirmed in Brazil in May of 2015. Since then, active Zika transmissions have been documented in more than 30 countries across the Americas region, with the number of confirmed cases expected to grow in the months ahead. Although the spread of Zika by mosquitoes has not yet been detected on the U.S. mainland, public health officials expect localized transmissions to occur this summer, particularly across much of the South, where the disease-carrying mosquitoes are common during the warmer months. Here to address the ongoing threat of Zika and to highlight specific actions that have been taken to mitigate the threat of the virus, we have three esteemed presenters. Our first speaker is Dr. Janet McAllister from the U.S. Centers for Disease Control and Prevention. Dr. McAllister is a board-certified medical entomologist with a PhD from the University of Arkansas. Currently, Dr. McAllister is the contiguous United States Vector Control Team Lead for the Zika virus at the CDC. Dr. McAllister, welcome. Our second speaker is Dr. Shannon Ledoux from the Carey Institute of Ecosystem Studies. Dr. Ledoux is a disease ecologist with a PhD from Duke University. Her research interests include community ecology, disease ecology, forest ecology, and ecological modeling. Recently, Dr. Ledoux has been studying the threat of the Zika virus in America's cities. Dr. Ledoux, welcome. Finally, our third speaker is Dr. Claudia Riegel, Director of the City of New Orleans Mosquito, Termite, and Rodent Control Board, a position she has held since 2010. Dr. Riegel previously has collaborated with government organizations and universities on a variety of research projects involving rodents, mosquitoes, termites, and a variety of other urban pests. Dr. Riegel, welcome. Each presenter will speak for approximately 15 minutes. Please feel free to submit your questions as they come up throughout the program. We will try to answer as many as possible at the end. Again, thank you for being here. Dr. McAllister, you can begin.
Thank you and welcome everybody. So I am going to speak a little bit about Zika virus and mosquito control, and before I really get into what some of the preparedness actions and things that need to be considered would be. So how is Zika virus transmitted and what is Zika virus? Zika virus is a virus, arbovirus. It is transmitted primarily through the bite of mosquito. However, it can also be transmitted from a pregnant woman who becomes infected to her fetus. It can be transmitted by sexual contact and also by blood transfusion. But primarily mosquito bites are the way most Zika virus is transmitted. And certainly the major concern for Zika virus in most people, it is not really a very severe illness. It may be a rash, a fever. It may have red eyes with it, but when a woman is pregnant and becomes infected with Zika virus and she transmits it to her fetus, that's where the real problems occur, because it causes severe birth defects and other severe abnormalities besides microencephaly in the unborn child. So the cycle of Zika virus, there is a sylvatic cycle, which is really not of concern here in the U.S. Because to date, Zika virus has not been transmitted locally in the United States. The epidemic cycle on the right-hand side of your screen, that's what's going on right now throughout the Americas, and you can see there that it's a mosquito bites an infected person, the mosquito becomes infected, and then bites another person and transmits the virus between people that way. So it is a mosquito-borne disease, and unlike West Nile virus, which people may be more familiar with, there is not currently a known animal reservoir outside of humans, outside of that sylvatic cycle. And the sylvatic cycle really is only non-human primates, so we don't expect that cycle to become established here in the United States. So next slide. This slide is the estimated range of the mosquitoes that can transmit Zika virus. You will notice that both of these mosquitoes are potentially widespread throughout the eastern United States and certainly the southeastern states, but all the way from California to the Atlantic coast, and particularly the Aedes albopictus as far north as Maine. Now, Aedes albopictus is not believed to be as important a vector because that particular mosquito will feed on more things than humans. So next slide. Just to give you a little bit of background of these mosquitoes and to so that you understand that this is a totally different beast than mosquito control districts have been dealing with in the past with the culex that transmits West Nile virus. So these mosquitoes bite during the daytime. They will also bite at night. They have a activity period around dusk and dawn, but the culex is a night biter. These ones really will bite anytime. The culex mosquito prefers to feed on birds, and that's actually where the West Nile is maintained in the environment. It is in the bird population. Aedes aegypti prefers to feed on people, so it does seek out humans, which is why it is a very good vector even at low numbers of mosquitoes. It also prefers to lay its eggs in man-made containers, and these containers can dry out completely. So the culex mosquito will lay its eggs in standing water that is not prone to drying out, whereas these mosquitoes, they will readily use very small containers that can be dry for months in between rain events. And then the types of traps that a lot of states and mosquito districts have been using to monitor for West Nile virus surveillance are not attractive to the Aedes aegypti or Aedes albopictus. So there's different traps that are needed for these mosquitoes. Next slide. And this is just a close-up of what those two mosquitoes look like. They have very distinctive markings on their thorax, so they are very easy to tell apart. And again, the one on the left, the Aedes aegypti, is really the primary mosquito for this transmission. Next slide. And this is just an example of the wide variety of habitats that these two mosquitoes can be found in, anywhere from clogged gutters to natural cavities in trees that can hold water. There are plants out there, bromeliad plants that can hold water, all sorts of containers that may be left out in the yard, pools that are not being used, anything that can hold water for 5 days in the peak of the summertime can produce these mosquitoes. Tires are a primary habitat for them, but certainly a lot of other places as well, including just, you know, that picture in the center with the red funnel. That's just a little cavity in a cement slab that used to hold a fence post, and that small amount of water is enough for these mosquitoes to breed. Next slide. So control for these two mosquitoes is really focused on the individual property level. The adult mosquito does not fly that far, and so when it comes to controlling these, rather than a more broad approach, it really targets the property level. And in the case of Zika virus, if there are travel-related cases, we are recommending that mosquito control be done around where that case property is and 150 meters around there to try and make sure that local mosquitoes don't become infected from that travel case. So next slide. So what can you do during the mosquito season to try and prevent Zika virus from becoming established? And that would be to implement all mosquito control strategies that are available. That includes addressing immature mosquitoes, monitoring for larvae, looking to see if you even have these two species in your jurisdiction, monitoring adult mosquito populations so that you know where they are, removing and dumping water sources where larvae can grow in public places, encouraging private citizens to do the same, larviciding in water sources that can't be removed or dumped. And then we also recommend that some sort of insecticide resistance testing on these mosquitoes be done so that if you do have to aggressively treat around cases or local transmission becomes established, you will be using insecticides that are going to be the most effective ones against these mosquitoes. Next slide. So what can you do if Zika cases are identified? Again, really doubling down on your mosquito control strategies, implementing that targeted vector control around that case or individual's location, really intensify the larval control and source reduction efforts, and consider adding some community-based adult mosquito control through residual treatments at the individual properties, or to do space treatments. I know in some states access to individual properties and doing treatments on properties is an issue, and so I would urge people to look at what their local statutes will and will not allow ahead of time, so that you know what mosquito control will be allowed within your jurisdictions. So next slide. This is where I really want to get into what you can do to prepare, because preparedness right now is really key activity. If you have not been preparing, you should start as soon as possible, because once that local case or local transmission is identified, that's not the time to start calling around and figuring out how you're going to address this. So identifying mosquito control assets in your state, because this may or may not happen where there's an established mosquito control district. Identify where the mosquitoes are found within your state, and CDC has put out a request for grant money through the ELC, and some of that grant money can be used to implement surveillance for these mosquitoes. Again, do some resistance testing, and again, those activities can be paid for through these ELC grants through the state health departments, but also are contingency contracts or intergovernmental agreements going to be needed or in place. So places that may not have a mosquito control district, is there a way within the state that intergovernmental agreements could be done where that district would be able to help an adjoining county to do some mosquito control if needed, or can contingency contracts with private mosquito applicators be lined up ahead of time? Also, incredibly important is to make sure that the lines of communication between the health department, the mosquito control, the emergency preparedness, other agencies such as Department of Ag or environmental health or emergency preparedness, all of the government agencies should be discussing, that need to be discussing Zika virus and Zika virus control, should already be meeting and discussing how they're going to react to this, but also that a point of contact in all of these agencies needs to be clearly identified and shared so that there's not any kind of confusion that's going around when and if Zika virus becomes locally transmitted. And then also really important to make sure that you have a communications plan lined up around control activities. You need to have something ready to go out the door. If you're going to do spraying in a community that is not used to being sprayed or having mosquito control done, you need to have some clear messaging to engage the public and let them know what it is that you're doing, why you're doing it, how it's being done, how long it's going to be done, and what all is involved there. So those are really the key things that you can be doing to prepare, or should have been doing to prepare for Zika virus. So next slide. I think for the communications, again, fact sheets on chemicals, press releases, frequently asked questions. Those are just some of the things that should be in that communications toolkit. Next slide. If you go to this website, cdc.gov/Zika, on the right-hand side, down at the bottom is a ribbon for communications, and there are a lot of communications tools that are available that you can be using as templates. We are putting together sample press releases and additional materials on that website. We are updating it constantly, adding new things to it, and so I would encourage that you use that as a resource. You can also click on the button for mosquito control professionals, and there is a document there on interim guidance for mosquito control for Zika, and then a document on surveillance and control of Aedes aegypti and Aedes albopictus, which goes into more technical explanations of the surveillance and the types of trapping and the things that can be done to survey and control for both of these mosquitoes. So we hope that you will find the information on our web page and use it freely. Next slide is my last slide. So that is it, and I am turning it over to Shannon.
All right, great. Thank you so much, Dr. McAllister. Those were very insightful remarks. Yes, we'll continue moving on. Dr. Ledoux, you can begin.
Hi. Yes, this is Shannon Ledoux. Thank you. Thank you, Dr. McAllister. That was a great introduction and covers a lot of the stuff I'm not going to talk about. I spend a lot of time thinking about the ecological interactions with the physical structure of a landscape and how that influences where mosquitoes are and then when and where they bite people. And next slide. So first I'm going to talk about how we think about risk, and that will set the stage for why my work is collecting the data that we're collecting and trying to interpret it in specific ways. So next slide. Generally, we think about risk of infectious disease as what happens if you drop an infectious person into a naive population. And so we talk about the basic reproductive rate, which is the R with a little 0 next to it, the R naught. And if R naught is greater than 1, then a new infection will result from the introduction of one infectious person. So these are directly human-to-human infectious diseases. This was a figure made and distributed by CDC 2 years ago, thinking about Ebola and putting Ebola in context of some of the other diseases that we all recognize. So for Ebola, one person with an active infection put into a naive population of people would on average infect 2 more people. This goes up to SARS. On average, one person would infect 3, and measles, on average, one person would infect 16. Again, luckily, we have treatments for many of these illnesses and vaccines. So this is when you have a direct human-to-human interaction. When there's a vector, such as a mosquito-borne disease, estimating risk is actually more complicated. Next slide. And so when we think about risk, and generally when I say risk, I mean risk to humans. When we think about risk in a mosquito-borne disease, we have to consider how likely it is that a mosquito will first bite an infectious person and then survive long enough to bite another person. And so we think more about the number of mosquitoes, the number of infected mosquitoes generated when you drop one infectious person into a new place. And so right now we have many travelers returning to the U.S. or coming to the U.S. Being diagnosed with Zika infection, and what we want to know is what is the relative risk in a given area that a mosquito of the right species would bite that person and be able to pass the infection on to the next person. Next slide. And so that's generally a function of how many mosquitoes are out there, right? It's not hard to imagine if you have more mosquitoes, then one is more likely to find that infectious person. It's also a function of how long the mosquitoes live. They have to survive long enough that they not only take that first bite, they take a second bite. Mosquitoes only bite humans to get blood in order to make eggs. So only the females bite, and they only do it at a specific time of their life. And then sometimes they bite more than one person before they make eggs. But sometimes they get a complete blood meal from a person, and so they're not going to bite that second person until a week later. And so how long they live is actually a very important parameter in estimating risk in a mosquito-borne disease. Next slide. And then finally, Dr. McAllister referred to this, who they bite is also a consideration. And different mosquito species have tended to focus in their native ranges on different types of animals. Mosquito species, for instance, that are going to bite from birds might only predominantly fly around at treetop level, right, at areas where they would find birds. Species of mosquitoes that are looking to bite mammals would have a completely different search mechanism. And if there are, in this diagram here, if there are 4 mosquitoes out there and 2 of them actually don't bite humans, then it's as if that vector density was cut in half. It doesn't matter that there are 4 because 2 of them aren't biting humans at all, so they're not going to transmit disease. And again, for Zika virus, right now, we don't think that there is a zoonotic or non-human animal reservoir for the virus. So when a mosquito bites a human that's infected and picks up the virus, if it then takes its second bite from something that's not a human, that's a dead end for the virus. It's not going to be then transmitted to, in this diagram, the cat. So these are the important mosquito ecology metrics that really inform our understanding of risk. Next. And we know that these parameters or metrics influence risk in some predictable ways. And in this figure, what I've tried to show here is if you look at the part that says baseline V, in this case, V is our risk, and so that's the kind of baseline risk. If you double density, which is M in the model, you double density, it brings your risk up in this 1 unit, right? So it increases risk 1 unit along this linear diagram. If you double the biting rate, so the frequency that mosquito bites humans, that's A in this, then you increase it yet another unit. But if you increase how long the mosquito lives, that's P in this diagram, then you actually increase risk quite a bit. And this is what really lends credence to the value of adulticiding, for instance. So if you can decrease the survivorship of adult mosquitoes, then you reduce P in this model, and you can see that reducing P should have the biggest effect on risk. So if you double all 3, then you move way out to the right on risk or transmission potential. And even if you double density and the human biting focus, the M and the A, but you decrease how long those mosquitoes survive by 50%, then you actually decrease risk below baseline. Okay, so these parameters are very important in assessing how likely it is that a mosquito would pick up Zika virus if somebody was dropped into a U.S. city that has, say, albopictus or aegypti. But they're also hugely variable in space and in time. And so, I don't think it's surprising that you can go from 1 yard or 1 block in an urban area to another and experience very different mosquito interactions. And so the parameters are really variable. And they're variable in space. And yet we often think about risk in terms of the mean density of mosquitoes or the mean survivorship of mosquitoes within a region. Yet outbreaks result when you get a series of these extreme events, right? When you have a location within the city where you've got this infected traveler and you have really high mosquito densities, not much else for them to bite, so they're biting humans, and conditions allow for the mosquitoes to survive long enough to bite again. So outbreaks result when the series of these kind of extreme conditions in parameter space align. Next. And so this brings me to the focus of some research I work on, which is investigating the mechanisms that define and maintain high-density mosquito infestations and associated health risks in an urban landscape. This is funded by National Science Foundation, Coupled Natural Human Systems Program, and their Long-Term Ecological Research Program. Next slide. And when we think about health risks, we're generally thinking about pathogen transmission, but in this study we're also, and I won't talk about it today, but I want to note that we're also looking at how the mosquito nuisance is influencing people's use of the outdoor space. Next. So we're working in West Baltimore, and largely we're working there because this is a long-term ecological research site, and we're north of the Aedes aegypti kind of permanent population for the most part. So largely what we're working with is Aedes albopictus, which is this vector that has high potential for being a vector of Zika virus and other viruses, but it doesn't always bite humans 100% of the time. And so how this particular species is going to, the importance of this particular species for Zika transmission in the U.S. is yet unknown. So we're working in West Baltimore. The city income is generally around $40,000, and we focused on neighborhoods that are either below that median, and those are the L's here, above it, which is the H, or right at the median income. Next slide. And when we look at different blocks within these neighborhoods, they have very similar structure. They were all built around the same time. They're row homes with kind of some shared green space. And from a GIS perspective, they don't look all that different. Next. There's about the same amount of trees. There's about the same amount of kind of grassy lots, so greenness or vegetation looks similar. Next. But when you actually zoom in, you get yards that look more like this one on the top here on the higher income neighborhoods, where we've got individual yards that are planted and managed and used. And when you get down to the lower income blocks, I don't know what kind of resolution everyone has, but if you look at the aerial view of this lower income block, you can actually see that several of these homes are missing their roofs. So we just have these standing row homes that are abandoned and have no roof. And on the left, the bottom left, you can see some pictures of what the outsides of some of these homes look like and the types of semi-permanent dumping sites that have collected around the abandoned lots. And so this is a pile of tires. But then there are also homes, and the red arrow here points to one that look like this paved yard where there's, you actually don't have much vegetation and it's very clean and there's nowhere for mosquitoes to grow in that yard. And so you have this kind of juxtaposition of both occupied and paved with high abundance mosquito habitat. Next. And we focus on these neighborhoods, and we go out 3 times a year and we do a comprehensive sample at the parcel level, so this is across some 1,400 parcels, of all standing water that we can access. We sample mosquitoes, we identify the mosquitoes, and then we dump the water. We also, every 3 weeks, go out, and the stars here represent places where we put BGS sentinel traps, so every block we trap for 3 nights every 3 weeks at 2 spots in each block, and then we knock on doors and talk to people about how often they're bit by mosquitoes. Next. And generally, we find a predominant vector, Aedes albopictus, which Dr. McAllister introduced. It's the Asian tiger mosquito. It develops rapidly in very small containers. We find a lot of them in those types of empty fence posts that she showed. They don't disperse very far, so we tend to assume that when we find larvae on a block, or when we find adults on a block, adult mosquitoes on that block, they probably were bred on that block or one away. They bite during the day, and again, they're known vectors of different viruses in different parts of the world. We also do find several other species, including West Nile virus vectors, but I'm not going to talk about those today. Next. And so first kind of summary, we find about 3 times fewer Aedes albopictus in those higher income neighborhoods, in those blocks. And we don't get a lot of variability block to block in the higher income. That's the black dots on this figure. However, the orange dashed line is about 20 adult female mosquitoes per night, per trap night. And that's currently a threshold that's being used in counties in Maryland to trigger the type of surveillance and treatment response that Dr. McAllister talked about around known Zika infection. So when somebody is diagnosed with Zika, and one of the counties in Maryland just had a traveler return diagnosed with Zika, if they sample and find more than 20 of these mosquitoes per night around that house, they will then treat. And so you can see that even in our high income block, which is 3 times lower than the other neighborhoods, they would have exceeded that threshold by July. However, if you look at the median income and the low income, you can see that they're not just exceeding the 20 per night, they're actually trouncing it. I mean, above 50, above 100 per night is actually huge. That's a huge population of mosquito vectors. Next. And I'll talk more about the variability in that slide in a bit. And when we look at the block-to-block variability across those neighborhoods, there's a positive association with the numbers of disused or trash containers on a block. So again, when we sample and we get high abundance of adults on a block, it tends to associate positively with the number of water-holding trash containers on that block. Next. And this shows that same data, but for larvae. When we look at the juvenile presence of Aedes albopictus, and these are in those water-holding containers, again, you can see there's huge block-to-block variability, with red being very high density of juvenile larvae and green being lower density of larvae and containers. Generally, when we find more containers, we tend to find more larvae. Next slide. And we find them in two types of containers predominantly, and I've talked some about the discarded, disused, or unmanaged. These are dumped containers. They can be anything from litter, like cups and bags, to things that I wouldn't classify as litter, like this pile of 7 tires that I've sampled 3 years in a row in one of our neighborhoods, and tires. But they're also, we do find them in functional containers, and these are important because they're containers that people put out and want out, and sometimes they're bases to these planters, or the rain gutters. Here you see the rain barrel. The screens aren't maintained, and so they're things that people have put out for a purpose, and they're often kept wet when the rest of the environment gets dry, which is important. Next slide. So again, it's important that there are these mix of trash and functional container habitats, and the mix is greatest. So we tend to find on the lower income neighborhoods more of the trash containers. On the higher income neighborhoods, we find predominantly functional containers, but we don't find as many. In these median income neighborhoods, we really see block-to-block variability, and you get both a mix of the kind of disused trash containers and the functional containers in close proximity. And so you can see that the green dots here are those middle income neighborhoods that have high variability from block to block in socioeconomic status and occupancy of homes. And so the green error bar is quite wide. The error around each of those dots is really large because you have huge block-to-block variability. And these are adult populations in this figure, but they're associated with the types of juvenile habitat that's out there, the water-holding containers. And I want to draw people's attention to the increase that's seen from July to August in the median income neighborhoods, while the lower income neighborhoods, which weren't significantly different in abundance before July, actually declined. That period is actually associated with low precipitation. So your disused containers, the kind of trash sites, dry out because it's not raining anymore in later July. But in the median income neighborhoods, you actually get an increase in populations because people are watering. And so you have enough yards and people there in the functional and enough functional containers that the added water is the added water and the maintained vegetation are maintaining higher relative humidity and water levels in those containers. And we see it play out with where the adult populations are highest. Next. So this is just a kind of a schematic of what we think is going on. And so if you have these discarded or trash containers, larvae, the number of larvae are associated with rain positively. But when they're functional containers, they're not associated with rain. When it's a container that somebody has put out and wants out in their yard, they tend to empty it when it rains a lot and add water. If it's a planter or a rain barrel, they tend to add water if it doesn't rain that much. And so you see this disconnect with precipitation. And then, at the bottom of this slide, you get more adults coming out of the discarded containers as long as there is rain. Next slide. But when there's not rain, you actually see more adults coming out of the functional containers. And so it's a little bit it's a little bit more complex than just, well, let's clean up all of the garbage and we won't have any more mosquitoes. Next slide. Okay, so all of this, we've gotten some pretty clear answers on where we find the most mosquitoes and under what conditions. But do more mosquitoes actually equal higher risk in a given neighborhood? Next slide. And again, risk is a function of some of these other parameters, like who are they biting and how long do they live, that should have more of an influence even than just mosquito density. Next. And we know that mosquitoes are out there biting. We get lots of complaints. This figure shows some earlier work that compared below median household income and at median household income neighborhoods and reported daily nuisance. We asked people, how often are you bothered by mosquitoes? And people, for instance, if you look at the Baltimore neighborhood 2, the circle above it that says M is a median income neighborhood. The circle is scaled to the number of mosquitoes we sampled in that neighborhood, which is a little less than the lower income neighborhood in this figure. But about 70% of the people said they were bothered every day, whereas closer to 50% in the lower income. And in DC, we did the same study, and 80% of people plus said they were bothered absolutely every day, even though they had very little actual mosquito abundance when we sampled. Next slide. So we get a lot of people saying they're bit every day, and saying they're changing their behavior. They're not going outside as much. And reporting that they've complained to the city. But the majority of those people that are saying they've complained and that they changed their behavior are actually in our higher income neighborhoods. This is of course important because that's often how control efforts are initiated. Next slide. But it doesn't always match with where the abundance is necessarily. But it's possible that you have high abundance in some neighborhoods, but they're not biting humans. So we went out and we collected mosquitoes that had blood in their gut, and we looked at the DNA in that blood that they had taken from vertebrates to see what it was that they were biting. And in our lower income neighborhoods, these pictures are scaled by abundance across low and median income neighborhoods in Baltimore. We got rats predominantly. These Aedes albopictus are biting rats when rats are present. But in the median income neighborhoods, they're biting rats and humans about half and half. And in the lower income neighborhoods, we saw rats, humans, cats, and dogs. In high income neighborhoods, we saw many fewer blood meals, and of the ones we found, they were predominantly human. And so there's a lot of mosquitoes in the low income neighborhoods, but they're not biting humans at as great a rate as they are in slightly higher income neighborhoods. Next slide. And I'm not even going to talk about the fact that they're biting rats so often. Obviously that is a talk for a different zoonotic disease on a different day, but it is something we're following up on and should be of concern. But this suggests that maybe the median income neighborhood folks in this figure here aren't complaining unduly. So when we sampled the juveniles, we didn't find quite as many as we did in the lower income neighborhoods, but the biting adults do seem to be finding humans at a greater rate in the median income neighborhoods. Next slide. So to sum up, in the lower income neighborhoods where we have a lot of abandoned sites and a lot of unmanaged garbage, we get a ton of mosquitoes coming out of that, but there's fewer people. And so when there's fewer people, the mosquitoes are biting what's more common. In these neighborhoods, it's rats. Contrary, in the higher income neighborhoods, you get more people and they want to use their yards more, but you actually have fewer mosquitoes that are breeding there. And because this mosquito doesn't fly all that far, the adult populations stay relatively lower than in the other neighborhoods. And next slide. And so the highest risk is in these neighborhoods where you have the block-to-block variability that includes both the mosquito habitat and the people present. These are often the same places where community greening and gardening is most active. Our urban landscapes across the U.S. have mandates to increase green cover. Community greening has gotten a wonderful support and is very active. And it tends to be in these neighborhoods that have enough open green space and enough people to actually make them active. So we're getting more people outside, potentially in a way that's adding more water back to the system that could be problematic given mosquito breeding. So many residents, the other thing, finally, one thing that I didn't talk about a lot, but we do talk to people and we assess housing quality and their experiences. Many residents in Baltimore and other U.S. cities do not actually have screens or air conditioning. That's important because when we think about risk in the U.S., it tends to be very different than risk in more tropical areas because most of our population are behind screens or AC. when it's hot or if they're bothered by mosquitoes. But there are pockets of urban poor that just don't have that level of protection. Many of these same people are also less likely to report mosquito nuisance as a problem. And so you could get outbreaks of a mosquito-borne disease in some of these locations that actually have time to amplify before anybody's alerted to the issue. Last slide. And of course, these are a lot of data, and lots of people have helped with it, including University of Maryland and Baltimore County students. And that's all I have. Thank you.
Thank you so much for those remarks, Dr. Ledoux. Those were very, very informative. We'll conclude today's presentations with Dr. Claudia Riegel, who will speak to us today about her work in New Orleans. Dr. Riegel, the floor is yours.
Thank you. Thank you. All right, so that was really a fantastic 2 sets of presentations, and I think it's a great segue to what I'm going to talk about. So, you know, here in New Orleans, I'm the director of the City of New Orleans Mosquito and Control Department, so we take much of the information that is out there and we put it into practice. So next slide. And you know, one of the things I wanted to cover today is really to have an overall understanding of what, you know, mosquito control in an emergency situation would be. In the case of Zika virus epidemic, you know, that definitely would classify as an emergency. And really talk a little bit about the basic principles of integrated pest management. So, you know, what do we actually do, boots on the ground? How do we conduct mosquito control? Also, it's important for everyone to know what kind of resources are out there and what are best practices and strategies. And so, especially with this particular, you know, situation with Zika virus, it has to be a multi-agency approach. Different agencies do different things, and oftentimes they complement. So it's very important to understand. And, you know, preparation, I cannot stress that enough. If it's getting the basic information of where these 2 mosquitoes are in your jurisdiction, or what resources are there, and who are the partners, all of that plays a role. Next slide. So, of course, we're talking a lot about Zika virus, but just a couple years ago it was chikungunya. And, you know, years ago, in 1905 in New Orleans was, you know, the last epidemic of yellow fever. And so at the time, lots of water holding containers, cisterns, water barrels, all of those things. And believe it or not, we're in 2016, and much of this is coming back around where there's a lot of green infrastructure. People are holding water in their backyards intentionally. So, and of course, we have to always remember that West Nile virus, St. Louis encephalitis, you know, Eastern equine, those diseases are with us every day. So what I do from a mosquito control perspective here is to talk about all these diseases, but of course today is the focus on Zika, which is going to take a bit of a different twist. Next slide. So when we're talking about mosquito control, districts or programs look very different. You know, some places you have one spray truck, it's a one-person operation. They may spray on a schedule down the street because it's June 11th, and that's, you know, they do a certain section. But funding is, you know, varies substantially from place to place. Some places have no districts, no mosquito control at all. In other places, they have full-blown programs, where New Orleans is one of those examples where, you know, we use a variety of different tactics and also heavily rely on surveillance, both the mosquito and then also looking at arboviral surveillance, working with, you know, the structure that's in place in the state to be able to give us information so that we can use evidence-based, you know, decision-making in our program. So I'm going to go through many of these that are listed here, you know, on the slide, and tell you a little bit about how we're implementing this in New Orleans. Next slide. So I think it's very important for everybody to understand what are the rules, you know, what are the laws that govern, you know, emergency declarations, or put the city or state in a state of emergency, so that, you know, during each type of scenario, you may have more access to properties so that you can do the work that needs to be done. But in Louisiana, it really is, it's the governor's office, the governor who has the sole authority to declare a public health emergency. You also have to work with the Governor's Office of Homeland Security. So operational activities of a public health emergency, that's who directs it. We also work with the City of New Orleans, is going to have to coordinate with GOSEP and the Division of Health and Hospitals. That's where the epidemiologist group would be. In the case of New Orleans, it's the New Orleans Health Department. It's going to be the lead agency for the public health emergency. So I think a great example that we just came from is Ebola, for example. So there's a lot of infrastructure there that's established. Next slide. And so the New Orleans Health Department is the lead agency, right, for the preparedness, for public health emergency preparedness and response. But our department is the lead agency for mosquito surveillance and mosquito control activities in Orleans Parish. So I think what these slides are telling you, or should be showing you, is that there's a lot of coordination that needs to happen between agencies within a city or a state. And of course there are a lot, you have to include Homeland Security, for example. They're coordinating all of the emergencies, which also is going to include disease outbreaks. And you've got communications, the Department of Sanitation, code enforcement, safety and permits, the police and the health department, the police and the fire department, sewage and water board, for in our case it handles the water in Orleans Parish. So everybody needs to work together in some capacity, but you cannot rely that one agency is going to be able to do everything. Next slide. So again, really a multi-agency approach. So here's a couple of examples that I'm going to talk about, but you know, each department has a role. And for example, we do the mosquito abatement, but yet we don't have any enforcement power. So we do rely on our health department code enforcement. We understand what city code is, what state code is, and we have to work together to identify those. And it may be that somebody from the health department or from code enforcement comes back and backs up, you know, as a supporting role for actual enforcement and adjudication. So sanitation, all these different folks are going to help address the conducive conditions, and there isn't any one program in the United States or I think anywhere that has the resources to do absolutely everything. And so that cooperation between agencies I think is incredibly important to maximize, you know, the resources that are there and possibly not to duplicate efforts, and so just to streamline the response. And also the coordination is going to help for quick ramp up of personnel to assist your mosquito control districts. And so we're 30 people approximately. If you add our summer interns, we're close to 40. But if there are numerous or multiple travel cases in Orleans, we are going to have to ask for assistance because much of it is boots on the ground. And so training, education of the staff and the people that may be helping has already been done on the front end, so that during a response is not the right time to be reacting and training and teaching. Responses go much smoother and I think more effective when all of that has been done on the front end. And of course, effective communication to inform the public, right? So we have to explain to the public what are the risks, what should they do, and it should come in a very clear communication, and all the different agencies should have some level of coordination so that there isn't mass confusion in the message. Next. So for example, some of the key partners that all of you should be looking for in your own jurisdiction or your own states, wherever you may be. Of course, your own health and hospitals, very, very important. Many of those have the epidemiologists in their group. In our particular case, they do the confirmation from the medical cases that come through, and then we get notified, you know, for the 100 block of where that patient may be. Government and non-governmental organizations such as NGOs, you may be able to pull people for boots on the ground, especially source reduction type campaigns, and I'm going to show you an example of that. There are some really great organizations out there. The American Mosquito Control Association is a wonderful resource. They have a technical expert, Dr. Joe Connellan, but there's a lot of information on the website And of course they do webinars. They're really pushing information all the time. In whatever state you may be, there may be a local mosquito control association that you need to tap into, and they may be able to provide some resources as well. And of course there's the National Pest Management Association, so they work with the pest control companies, which also we work with closely because they are also boots on the ground. They have relationship with customers, and we're really pushing for them to really turn over a lot of containers. And then also many of them do backyard treatment. So it's an opportunity there for the mosquito control professionals to really push out best practices to those folks. Colleges and universities, I'll give you a few examples here in Louisiana. We've got Tulane, LSU, and Nicholls State that we work with very closely. Some wonderful professionals there that bring a lot to the table in understanding about mosquitoes and research. And of course you need to look at the private industry that is there. So there are many large companies that are out there. This is their business. It's good product stewardship, and so that's available as well. And also key partner, I would say, is the media, because there's just been a lot of conversation about Zika virus, and so try to take those opportunities when you can to push out the message, education, and keep people informed as needed. Next. All right, so if anyone is interested, there's a, I don't think the comprehensive plan is placed on the website. There's a shortened version of it, but you can always reach me if you need to see the full version of it. But we placed this out on the website earlier in the year, I think beginning of April, and it really outlines what we're doing, how to do it, and how to ramp up. So there's an escalation depending if there is no travel case, if you do get a travel case, or if there's mosquito-borne locally transmitted cases. And so it talks about the different organizations, what their roles are, and it also has a pretty detailed outline of where Aedes albopictus and Aedes aegypti, which we have both, are located in New Orleans and throughout the state. And also, you know, it explains the different components of mosquito control. Next. All right, so let's go back to the basics here and how, you know, what are we doing as far as, you know, finding out where these mosquitoes are, how do you respond, how do you do public education, but let's start first with surveillance. And we'll go to the next slide and we'll go through each one. Next slide. So trapping for adult mosquitoes, it really takes a variety of different traps. I just wish there was one trap that would catch them all, right? That would make our jobs very easy, but that is not the case. And, you know, primarily we've been focused, if you look at the bottom left, is the gravid trap. And so that really catches those southern house mosquitoes as gravid females that are going to lay their eggs. And so we collect those, and we still collect those each week, and we send them for testing on Wednesdays. But the reality is that does not do, those traps do not do a great job of collecting Aedes albopictus and Aedes aegypti. So it takes a variety of different ones. The top right, no, top left, that's a CDC light trap, and they don't do a great job, but it gives you a good profile of what may be out there. And of course, we're sitting in an area with lots of marsh, and so if you look at the top right, those are the New Jersey light traps, and those do a relatively great job of collecting some of those mosquitoes that are out there coming from the marsh. But the bottom two, which are going to be the bottom center and the bottom right, that's the, you can see the bottom right is the BG Sentinel traps, and that's one of the traps that we've purchased in great numbers over the last couple of years to deploy so that we can collect adult Aedes albopictus, Aedes aegypti mosquitoes. And of course, in the middle there with the little stick is the little cup. It's a little black jar, but that in that case is just a little cup with a stick. And all those little black flecks, those are eggs. And so we place those out to at least look at the species that are in a particular area, and so that's how we use those. Next. So of course, the one thing that you'll need to do and what we've been working on is really assess the areas of risk, high risk, in your district. And that's why I love Dr. Ledoux's presentation just a few minutes ago, because we often deal with many of those types of neighborhoods as well. And so where are you going to put those traps out? And if you don't know where the Aedes albopictus or Aedes aegypti are located, you're going to have to do some sort of survey using the little cups perhaps to find out the locations, and then you can help determine, looking at housing, looking at conditions, dumping, abandoned lots, population density. Those are all different types of things that you would take into consideration, in addition to travel and where your visitors are going to and where they're spending time. And so it all costs money, right? You have to determine what the additional costs are going to be, labor and equipment. And really labor is the big cost. I think I just lost my slides. Did I lose my slides? Okay, very good. And you should always prepare when you can before the season. If you have not done these things, tomorrow is the right day, to get started. And so we also have a system and you should have a system for getting calls from the public. In the case of the City of New Orleans, they've adopted a 311 system. We worked very closely with the folks at 311 on a script. So if anyone is interested, just please let me know. I'd be happy to send you our script. And so it really asks for those key questions, but at least you get the information. Of course, each one needs to be identified and inspected so that we verify what really is going on. But regardless, you're going to have very good record keeping and some sort of mechanism for evaluation and then to continue monitoring. So in the bottom, you can see our graph there. This is from 2012 when we really had a very active West Nile virus season. But if you have GIS capacities in-house or tap into some of your other agencies that may be part of your organization, see if they can start plotting these things so that you can look at, the greater picture of what's happening in your district. Next. All right, so education and outreach, I can't stress enough. It's, to be completely honest, it's a very difficult thing, to manage and to get your message across. And how do we, if we do a press release or if we do in this particular case, we had the mayor discuss the importance of mosquito control, which is super, and he's being proactive, but we need to translate that into people turning over containers and actually listening to the warnings. And so it's really a multi-agency approach. Again, Centers for Disease Control, they have really wonderful information on the website. It's been vetted. It's accurate. They love that you cut and paste. That's what we do. We always verify and double check. And you want a nice clear message with your state epidemiologist group. Communications, is often involved depending on the size of your organization. And you want a unified, easy to understand message. Have your press releases done in advance. It is so much easier, trust me on this one, because it's happened to us already. In past years, it's much easier to have your press release ready to go and then you just modify as needed than to create press releases under stress because you're already busy. Education on personal protection, so super important on the use of repellents, physical barriers and screens, and Dr. Ledoux is absolutely 100% correct that a lot of people do not have screens, they do not have the means to have air conditioners, and so their windows are wide open, and they also may have a building that does not allow for screens to be installed. So I think that's a big myth that we have in our country. And anyway, so also, and in this particular case, you also, because it is potentially, well, it is sexually transmitted, also work with your own health departments to provide some support and backup on those messaging as well. Make sure, I'm an entomologist, and so I'm not a medical doctor, I'm a bug doctor, but the reality is there are questions that are medical questions that should be referred to a physician. And so you may know those answers, but it's always important to refer them back to their own physicians, or your health and hospitals may have a 1-800 number that's going to put them directly to the right person to be able to answer those questions. Next slide. All right, so prepare your fact sheets in advance, okay? It gives you time when you're able to do these things in advance. It really helps you, you're able to think about it, you're able to get it checked, verified, all of that, and there are going to be a variety of different audiences that you want to target. And so I'll just give you some examples. We've got everybody from military to tourists that come into town, to mission groups that go abroad, do mission work and come back to New Orleans, your general public, your pest control companies, your pet owners, all these folks are asking questions. And so you may need to tweak those messages. There's a lot on the City of New Orleans website, and also CDC has quite a few. Another one that comes up, and in fact I just had a question today about it, is the risk communication regarding pesticides. So we use pesticides in our organization, and I think most mosquito control districts do as well. So make sure you have a full understanding of the reasons how these products work, why you use them. It's really going to help with the ability to continue to use them. Prioritizing, right, areas, a demand for rapid response, all those things should be probably written in your Zika plan that's there. Beekeeping, organic farmers, there are some folks that are chemical sensitive. Louisiana Department of Ag and Forestry in our state has a list, so make sure that pesticide applicators are doing the work and that notification is in place. So write your standard operating plans, right, or communicate it with the agencies. In New Orleans, we've started doing this very, very early this year. In fact, January, we really started the push, but even before that, over the years, we've met with the fire department. They know what products we have. We met with communications. It's really important to let people know what mosquito control districts are doing so that you can do your job. Next. So here are just some examples. You can go onto the City of New Orleans website and pull these off. But so the one on the left side is really a little bit higher level, targeting mosquito control, life cycles, even some of the diseases that they can transmit. But that's a pretty wide audience. And then of course our health department produced some that are health related, targeted to healthcare providers. Next slide. Okay, so source reduction. So this is, this is really a challenge. Just yesterday, we were targeting a neighborhood called Bywater. It's an area, very mixed income neighborhood. A lot of gentrification going on in that neighborhood. So you see everything from very high income to low income housing and everything in between. So, the gutters, the containers. Unbelievable what numbers of containers, and my previous speakers have showed many of those. I'm not going to talk about it too much, but I did show, I put two different kinds of containers, I guess, are water bodies here. One's going to be sort of that canal on the upper right-hand side. So we get a lot of those types of calls about Zika virus. So just make sure that you understand the biology of these mosquitoes, because really the reality is that's really not the right habitat for Aedes aegypti and Aedes albopictus, right? Other concerns that go along with it, but not that so much. And that even includes the swimming pool, the abandoned swimming pool that's at the bottom. So it's, we appreciate getting the information. We are going to deal with it, but also use that opportunity for a lot of education along that goes with it as well. Next. So physical control, look, it's all about removing the water containers. And in this case, we're not really dealing with tidal areas for this disease, but removing the standing water as far as backyard containers, we were going door to door yesterday, and we've been doing these campaigns each week, and they're large campaigns. It's going in, knocking on the door, talking to that person and saying, look, do you mind? We're doing a mosquito campaign. We want to remove containers, turn things over. Many people let you write in, which is great, and many people say, no, I really stay on it. But we kind of push a bit to say, look, great, that's fantastic, but do you mind if we take a look anyway? Sometimes our inspectors find things that maybe you may not pick up. And I'm telling you that 9 out of 10 times we are still finding containers that are breeding. So just in my little event yesterday, from the houses that we found, about 75% of those containers had larvae in them. So it's really a high proportion when we do find those containers. Next slide. So these are some of the examples, right? And so again, it goes back into property access. All right, you have to understand what your local authorities are allowed to do. Of course, if a homeowner gives you permission right there and then to come in, well, that's great. Please understand your city code, and a lot of times city code is often slow at allowing inspectors to go onto the property. Now, of course, if it's abandoned property, in our case in Orleans, we have full access. We can abate as needed. But we just changed the laws here, which is great. A new ordinance was passed about 2.5 months ago, and now we can give homeowners 24-hour notification only, and then we can come back and abate and inspect. So that really reduces the time from, let's say, working with a homeowner that just does not want to give you access. But, you know, for me, that's very important because, for example, we've had one travel case already in Orleans, but this ordinance was not set up. But also, it was in wintertime, so the overall risk was much lower. We had few mosquitoes. However, now that's not the case, and so we want to go to every single property around the area of a travel case, or if we were to have locally acquired mosquito-borne cases, we want every single property. And so 24-hour notification really is going to increase our ability to do that kind of work. Understand what the waste tire policies are, and I say waste tire here, but it's really, you know, used or discarded tires. Oftentimes, LAEDEQ, they're interested only in waste tires, but City Code covers all the tires. So enforcement is very important. Those enforcement agencies, I cannot tell you how important they are to keep those tires out of people's yards. And also, there may be some policies for residential pickup of tires that homeowners just don't know about. You know, for example, in Orleans, on the second tire collection or second garbage collection of the month, homeowners can stack up to 4 tires next to their garbage cans, and the city will pick it up. Most people don't know that, and so we really have been pushing on that message so that people don't just store tires in the back. It is common to find tires in people's yards. Next. All right, so this is the example that, you know, one of the areas that we've been working at. We just finished it up yesterday. It's a huge area. It's called the Bywater. This is an area where a lot of mixed housing here. As I had previously mentioned, lots of areas that still have dumping going on. However, lots of Airbnbs, people are outside. Excuse me. It's a real trendy area, and so, and we have Aedes albopictus and we have Aedes aegypti in abundance in these 2 areas. And so this is where we went door to door over the last several weeks and really trying to push down those numbers of mosquitoes. Next. Also, biological control is an option if you have the infrastructure to do it. Fish, copepods, cannibal mosquitoes. However, sometimes they take a lot of manpower and rearing to do so. Fish is something that we've implemented for many years, especially after Hurricane Katrina and swimming pools. And also now we've ramped up our copepods, and that's what we're using in small water holding containers as a supplement. Next. So control measures, so we've got lots of options, and these are wonderful tools. You just have to have good stewardship and also check for resistance testing, very, very important. But using ULV, ground, aerial, timing of application is very important. We do not spray during the day, but we've worked over the last couple of years looking at timing of application at you know, very early in the morning and at sunset as well. Aedes aegypti can be, and we see that it is crepuscular, so very, you know, could be active during those time periods, and so we've been doing work with that, and that's a tool that we implement. And also in the last couple of years, or last year or so, is looking at residual yard treatments. So there are options out there, especially in the case where you have a travel case where you need a long residual. That's a great application for where that can be applied. And there are lots of different types and formulations of larvicides. As you're going yard to yard, of course, you have to be an applicator to apply, but it's very important, and it definitely is a tool for keeping those mosquito numbers down. Next. So very important, you have to think about the budget, right? These products are very expensive. Who's going to be applying? You need to have certified applicators, and they need to be, you know, their licenses need to be up in place. So if you're thinking in your own area of getting a district together, there's quite a bit to consider. You just can't go out there, buy a spray truck, and go on your way. Oftentimes we have to keep a variety of different products in inventory. because they come in a variety of formulations, different uses for what it may be. And of course, you have to test these products against your own local populations of mosquitoes, because if you have resistance in your population, you may be using product A that is really no longer effective against your resident populations of mosquitoes. So very important to be able to do that. If you're not able to do that but have the capacity of doing treatments, work with another district that can provide some assistance with that. Next. Anyway, so pesticide stewardship, I cannot stress that enough, okay, from a safety standpoint, from an efficacy standpoint. Make sure that you're in state and federal compliance, very important. Make sure that your people are certified and continuing education. Know your local requirements. Personal protection, right to know, all these things come into play if you're doing any kind of pesticide applications. Record keeping and permits, you're going to have some requirements locally. And also get your contracts, if you have any contingency contracts, in place now. So it's very important to get contracts in place before you have an issue. Next, or an emergency. Resistance management, I cannot stress that enough. Okay, so in this case, we actually do much of this work in-house, but if you don't have the capacity to do it in-house, work with another district. Actually, Dr. Janet McAllister and her labs at CDC are incredibly helpful, but there are a lot of folks that can be helping with this, and there are some serious implications here for mosquito control. So you want to be using the right product that are actually going to kill your mosquitoes. Next. And evaluate your effectiveness, right? So very important, and I'm going to continue on here because I think we're short on time, but very important to continue effectiveness. And I included this sheet here about calculating the cost activities related to Zika virus. So, you know, a lot of people that I talk to have no idea what it's going to cost them, right? Or what is it going to cost? So I hear a lot of numbers pulled out of the air, but this is something that we've implemented already, is we'll know what it costs us. Our staff in its entirety, they do a daily activity sheet. This is actually based on FEMA reimbursement sheets. We just modified it a bit, but it gives you vehicle usage, and I say emergency response there, but that's the one that we're actually talking about is with Zika. So we're documenting that time spent, activities on what it's going to cost us for Zika virus response. Next. And preparation, frankly. Anything that's above and beyond, you know, what we would normally be doing. So the main thing from a district standpoint, new information is constantly available. And I also want to make a note here, too, that there's a lot of bad information that is constantly available. So just make sure that you're verifying information, really contacting the experts that are in this particular area so that you're really, you're not disseminating bad information. Start your preparations early. We're June here. It's 92 degrees. Yesterday on the streets, walking around, it's hot. You know, 5 days, egg to adult, 5 days, very, very quick. And so you need time really to inventory, to determine your needs, work with other agencies. There is additional funding that seems to be coming down the pipe. So make sure that those are accounted for and good proposals are placed in there. You want to do an integrated mosquito management approach, and frankly, it's required. And so it's that source reduction, it's the education, it's the use of pesticides, it's all together, biological control if you have the capacity. And responding to Zika virus really does require a multi-agency approach. Work with your other districts to really enhance resources and the response, and be transparent, okay? Keep the public informed, work with your communications department, but websites, media, Twitter, whatever it may be, those are all great options for disseminating information. I think that's it. Next slide. Okay.
Okay, that concludes our webinar. Thank you for joining us.